a recursion is a function that calls itself until a base is met. A base is basically a condition. We will explain it with examples. However, before that, recursion is hard to understand and it's harder to implement because there are many cases where you could make silly mistakes that cause stack overflow, and we'll talk about stack overflow as well. I would suggest not using recursion unless you really need it, because it easily can cause like stack overflow. And to understand recursion, we need to understand how call stack works, and I'll explain call stack shortly. An example for recursion function, let's make it recursive. It takes a number. Now return recursive num minus 1. Now recursive takes a number and returns itself with the same number minus 1. So let's say we call it with recursive 10. This will come back with 10, 9, then 0, then minus 1, infinity. Like, this causes a stack overflow because, well, the function runs and runs again forever, so the browsers do not accept it, the engines. So this is recursion without a base. A base is simply a condition. It's like if num is equal to 0, basically return. And let's console.log num. Now if we go here and do this, we see 10, 9, 8, up until 1. So it's like a loop. It's like for let I equals to 10, I is equal to 0, I minus minus. This loop says I equals to 10, so long I is not 0, decrement I. It's the same thing as this. However, in some cases recursion helps. This is an example, a simplest example of recursion. But even here, you could make big mistakes. Like if you do num minus minus decrement, it causes stack overflow. Look, it should cause stack overflow. Let's just get back and okay, and yeah, it causes stack overflow. Why? Because decrement keeps the value, then decreases 1. So keeps the same value the first time, then decreases 1. So when the function is invoked, 10 is 10, then is 9. Then the function is invoked again, it's the same, like 10, then it's 9. So it will call itself with 10 forever and decreases 1. That's why I say like recursion could be very, very difficult to implement. But what is call stack? Well, call stack is a place in memory. Is if we go to call stack, it's like this. You have several functions, like function 1 to 10. If they depend on each other, these functions, these black blocks, we call them functions. Say these functions depend on each other to implement. How do functions depend on each other? Well, we will make a small test. Function 1 console.log 1, function 2 console.log 2, function 3 console.log 3, but before that call 1, call 2. We have to call 3 here. So we have 1, we have 2, we have 3. Why? Because this function called this function and it returned 1. Then this function called, the same function called 2, it returned 2. Then it implemented this. So the function 3 depends on 1 and 2 to be successful to return itself. If we have more, like in case of recursion, we have this function depends on itself, the number of times this is implemented. So say 10. The first time it comes with 10, it comes with 9, then it goes to 8, then it goes to 7, like that. And when the base case is met, first it pushes away like 1, then 2, then 3, up until the end. Why? Because call stack is called first in, last out. So it's a data structure, a stack data structure. First function that comes in, it goes out last. So the first time we had 3 functions. The first time 3 was called, but it depended on 1 and it depended on 2. And the first one that went out is 2, then 1, then 3 itself, and wins, and it moves these things out. This is exactly how recursion works. You say like, call this function, call itself like a number of times, unless it is 0. So call itself 10 times. It calls itself 10 times and it later like pushes the functions away. However, if there is no condition here, then this function calls itself 1,000,000 times until this stack in the memory, that is a place to store functions and to invoke them, it says, okay, I'm full, there is no place, and it causes stack overflow because it overflows with functions and the engine cannot accept it anymore. So recursion has many difficulties and it's dangerous to implement, but our first example like was the case of decrement. I'll show you another example of recursion. Let's say we want to reverse a text, so reverse string. With recursion we can say function recursion takes a string. The base case is if string is equal to an empty string, then return an empty string. Otherwise, what do we do here? Well, we return the function itself, that's the first thing. Then we remove 1 from the string, like let's say const text equals to hello world. So we remove 1 from here. How do we remove 1? In JavaScript we remove it with many things, like you could use slice, but for string there is another way, which you could say like str.substr and give it a number. If you give it num, it will remove 1. So it will be like hello world but without an h. Now we don't want just that returned. We want to also return str char at 0. So the first time this function runs, it takes this text. We give it a condition that if the str is empty, then return, no longer run. It comes here, it sees recursion, string or text, remove 1 from the string, like make it hello, and add it to the end. So make it like that. The second time it will be like this until the string is empty. However, the danger is if we only put this here, it will cause stack overflow, because the string now is always like this is removed, this is added to the string. So this string, the next function that runs, sees this string as like this, not like this. However, if this is out, this function, when it runs, it sees it like this. It just sees things like this, because what we are returning is not the string added with like with a letter behind. It's something else. So that's why this works, but this causes, like, if this is inside this, it causes a stack overflow. But let's just console.log string and see what happens if we recursion with text. If we try it, we see hello world, LOL, like this, up until this is met. However, if we give it const sample equals to this and console.log sample, let's see what happens. See, the function sees the string, it reduces one character each time, like removes one character each time until it reaches the end where the string is empty. Then it returns. It adwins and gives you the text reversed. And this is a good example. But it's always a bit dangerous to do recursion because of Stack Overflow and things like that. But it's also very interesting. Sometimes like interview questions can ask you about recursion, how it works. So you could always be prepared. Thank you.